Good afternoon, class. Chapter 8, further applications of trigonometric functions, use 8.5, polar form of complex numbers, the complex plane, the Moivre's theorem, and we're going to continue with the second part. So we want to find complex roots. We're going to let W be R cosine of theta 0 plus I sine of theta 0, and n is larger than or equal to 2, and we have n distinct complex roots. So z sub k, which is the kth root, is nth root of r, and we are going to write cosine of theta 0 divided by n because we want the nth root, and we add 2k pi divided by n, and the same thing for the argument of sine. And k can be any number from 0, 1, 2, all the way to n minus 1, and bear in mind, we could have 360 degrees times k instead of that if it's in the form of degrees. So we want to find complex cube root of -4. So how do we find that? First, reminding everyone that if we have a positive value, for example, 10 is 10 cis 0. But if it's minus 10 is 10 cis pi. So minus 4 is 4 cis pi, or 4 cis 180 degrees. And the reason n is 3 because we want the cube root. So I hope that's pretty straightforward. Let's do the math, everybody. And again, reminding everybody that we can have instead of that 360 degrees times k divided by n. We can do that. So force is 180, and we want to get the cube root. So z sub k is the cube root of this number 4, and cis 180 divided by 3 plus 360k divided by 3. So this is how we write that. Let me erase my work. So one more time. Since we want the cube root, we're going to write cube root of 4 cosine of 180 over 3 plus 360 degrees k divided by 3. You can write cis or just cosine of this I sine of that. Either way is fine. So it's pretty straightforward. So all you have to do now, do the math. Let's divide by 3. So again, a quick recap. Minus 4 is 4 cis pi. You can go with the radians. It's easier to work with the degrees. So 4 cis 180 degrees, n is 3. And the reason is 3 because it says cube root. So basically, they are asking for cube root of -4. That's what they're asking. So just to give you an idea, what is that equal to? If you call it x, just so you see, and I raise it to the power of 3, that means -4 is x cubed, and then you say x cubed plus 4 equal to 0, and you solve. Now, if we had x cubed plus 1 or a number like that, that the cube root was known, it could be easily factored. I remind you of what we did in algebra to solve something like that. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. Please understand this is not a perfect square trinomial. If we had a plus sign here, we would have a plus sign here, negative sign here. Okay. And for example, x cubed equals 1. You know, one of the solution is 1, and there are two more solutions that are complex. And that's what we are doing here. We are finding the complex solutions. Or let me erase again. Just remember this, okay? These are identities that help with factoring. All right, so here's what we are going to do. We are going to divide this one by 3, we get 60. We're going to divide this one by 3, we get 120 degrees. Don't forget the k. Now, choices for k. 0, 1, 2, all the way to n minus 1. Because n is 3, you can go all the way to 2 and you stop. So if I plug in 0, everybody, so just drop this. We get cube root of 4 cosine of 60 plus I sine of 60. If I go with 1, 1 gives me 120 plus 60, so it becomes 180. So cube root of 4 cosine of 180 plus I sine of 180. If I replace the k with 2, 2 times 120, 240 plus 60, 300 degrees. So we have all three here. So what does it mean? The modulus of z or r equals square root of x squared plus y squared. All cube roots have magnitude of cube root of 4. That's the magnitude. Magnitude is referring to a scalar and it's positive. The arguments are 60, 180, and 300 degrees, which means equally spaced at whatever this 2 pi or 360 divided by 3 or 120 degrees. So it starts from 60 and then you add 120. That's the 120k. All 3 points are equally spaced on a circle x squared plus y squared equals cube root of 4 to the second power. Looking like that, class. So this is a circle centered at 0, 0, and the radius is cube root of 4. Okay. One point something, 1.5, 1.6, roughly 1.5, 1.6. And they are 120 degrees apart. So the first one is at 60 degrees. So this distance is cube root of 4. This radius, cube root of 4. 60 degrees. Then add 120 degrees, you get 180. Add 120 and you get 300 degrees. So this angle, this one is at 360 degrees. So those are the three numbers. So we wanted to find complex roots, and we have it in this format. If they ask you to put it in a rectangular format, in a standard format, then you replace each one. For example, cosine of 60 is 1/2. So for example, you replace this one with 1/2, and you replace this one with square root of 3. If they ask you, you don't have to when they don't ask you. They want the roots in this format. 180, this becomes 1. this becomes 0. Again, as an example, if they ask you, let me use a different color. If they ask you, you replace this with -1 and this one with 0. At 300 degrees, the reference arc is 60 degrees, which means the same answer as 60 degrees, but depends on what you're dealing with. So for 300 degrees, cosine is the same as 60 degrees, so 1/2, but sine is negative because in the fourth quadrant, cosine is positive, sine is negative. So if they ask you to write it in that format, you should have no problem doing so. So this is how we find complex roots. Uh, Again, just 1 is 1, 6, 0. I mentioned this concept of a 0. So the first one starts at 0. And then remember the difference of 120 degrees. 120, another 120 is 240, another 120 gives us back. So at 0, it starts with 0. And you divide 360 by 3. So the same 120 degrees work for any cube root. The question is, where do you start it? For 1, you start from here. In short, for any positive number, you start from here. For any negative number, you start at 60 degrees. Just to give you an idea. Plot 3, -4i in the complex plane and write it in polar form. So 3 to the right, -4, 4 down, 3 to the right, 4 down. So z equals 3 minus 4i. Very simple. This is the angle in a positive direction. Tan of theta is y over x. So -4/3. And therefore, tan inverse gives you alpha, everybody, because of the limitation. Remember, for the tangent, in order for it to be 1-to-1, we decided to go from negative power to power 2. That's why when you use a calculator, you put this into a calculator, it's not a common arc. You put it into a calculator, it gives you -53.13. It gives you the fourth quadrant. So what is alpha? Just add 360 degrees. Add 360 degrees. Theta is 360 minus alpha, and that gives you 306.87 degrees, everybody. Again, very straightforward. To write it in polar form, RC theta, we have to find the R, which is the square root of x squared plus y squared. That means 3 squared and -4 quantity squared. So we need to find the R. This is 9, again 3 squared is 9, and then this is -4 squared is 16. and they add up to 25. And R becomes 5. So Z, which is A plus BI or X plus YI, is R cis theta. So replace the R with 5. And theta with 306.87 degrees. You can just write it using shorthand notation. 5 cis 306.87 degrees. If you want to write it in that format, it's just as good. It's not a big deal. We are ready to move on. We want to use the Moivre's theorem to write 2 plus 2i to the power of 6 in the standard form A plus bi. In other words, we want to raise it to the power of 6. To raise it to the power of 6, we are going to follow this. Z to the power of n is R to the power of n cis n theta. So we need to find the R. And R squared is x squared plus y squared, so 2 squared plus 2 squared. So this number, 2 plus 2i, we want to write it in polar form. So this number, 2 squared plus 2 squared, which is 8, and therefore 2 squared of 2. So it's pretty straightforward. Now, we also need to find theta, which is tan theta equals y over x, and adjust it for the quadrant. Since both of them are positive, it puts us in the first quadrant. We don't have to worry about it. So theta is tan inverse of 2 over 2. And of course, 2 over 2 is 1. The answer is powerful. So 2 plus 2i is 2 squared of 2 cosine of power 4 plus I sine of power 4. Or again, if you want to go with the shorthand notation, you can write 2 squared of 2 cis power 4. That's just as good. We are going to raise this to the power of 6. So according to this, we're going to raise r, that means 2 square root of 6 to the power of 6, and then we're going to multiply the theta pi over 4 by 6, because we are raising it to the power of 6. So let's see what happens here. This class is 2 to the power of 6 times, now square root of 2 to the power of 6 means 2 to the power of 6 times 2 cubed. Square root of 2 to the power of 6 is the same as 2 cubed. So we have 64 times 8, which is 512 this 3 power 2, 512 cosine of 3 power 12 plus I sine of 3 power 2. 3 power 2. 3 power 2 cosine is 0. Sine is 1. So we get 512 times 0 minus I, or minus 512 I as the final answer. The most. Find products and quotients of complex numbers in polar form if Z is 3 cis 130 and W is 4 cis 270. What is Z times W? So I'm going to multiply two numbers, complex numbers in polar form. Z1, Z2 is R1, R2 cis, theta 1 plus theta 2. Therefore, we just follow that. 3 times 4, because R1 is 3, R2 is 4, R1 times R2, 3 times 4. Cosine, or cis, 130 plus 270. Cosine of 130 plus 70, I sine of 130 plus 270. Three times 4 is 12. 130 and 270, they add up to 400. We can subtract 360 and we get 40 degrees. And we are done. Note that 40 and 400 degrees are coterminals. Now, of course, if they want you to continue, this is not a common arc. You can put it into a calculator to find what is cosine of 40, what is sine of 40. You want to go to a rectangular form, okay? Standard form or rectangular. Find complex roots. Find the complex cube root of negative 1 plus square root of 3i. Leave the answer in polar form. Use degrees. Normally, it's easier to use degrees. And here's the synopsis of what we do in order to find the nth root. So the nth root would be the nth root of r cis theta 0 over n plus 2k power n. So the very first thing we have to replace this with its polar format. So in other words, we're going to convert it to its polar form. And to do that, we need to find the r first. So r is the square root of x squared plus y squared. That means square this number and square this number under the radical. This is okay, so everybody knows that. Okay. One, 3, they add up to 4, so it comes out as 2. Now, x is negative, y is positive, puts us in the second quadrant. So it's tan inverse of y over x, or square root of 3 over negative 1, or minus square root of 3. Remember, square root of 3 gives you 60 degrees, minus square root of 3 gives you negative 60 degrees if you put it into a calculator. However, quadrant 2, you have to add 180 degrees, or pi. So again, you adjust it for the quadrants. I can't emphasize this enough. You have to figure out what you should do. Therefore, this number is r cis theta 2 cis 120. So negative 1 plus square root of 3i is 2 cosine of 120 plus I sine of 120. And now that it's in the polar format, we can use z sub k. So according to that, it would be the nth root, cube root, so cube root of r, so z sub k would be cube root of r, which is cube root of 2, cis, you are going to divide this by 3, and then add 2k power n, or 360 degrees times k divided by 3. So again, either that, or in this case, we're going to go with the degrees 360 degrees times k divided by 3. So what do we do? Obviously, we're going to divide by 3. We've done this before. This is 40. This is 120. And we can use 0, 1, 2. If I use 0, basically just 120k goes away. If I replace it with 1, I get 120. With 40, they add up to 160. If I replace the k with 2, 2 times 120 is 240. with 40, I get 280. So cube root of cis 40, cube root of 2 cis 160, cube root of 2 cis 280 degrees. I'm going with the shorthand notation, everybody. We're done with that. Let's look at the graph. So we have this question. We want to find the cube root of -1 plus square root of 3i. We're going to leave the answer in polar form, and we found the answers. So as far as the polar format is concerned, you have a circle centered at 0, 0. And this is the radius. This is x squared plus y squared equals r squared. So this is the radius, okay? And you start with 40 degrees, 160 degrees, 280 degrees. Therefore, all 3 points are equally spaced on a circle of x squared plus y squared equals whatever this number is to the second power. Okay, everyone, this number to the second power, and I can't emphasize this enough. So you have a circle centered at 0, 0. This radius is cube root of 2 to the power of 2. So x squared plus y squared equals cube root of 2 to the power of 2. And you have 3 of them. This one is at 40 degrees. We have it here or here. Okay, 40 degrees. Then we add 120 degrees to that, puts us here. Okay, 120 degrees. So it gives us 160 degrees. Then we add another 120, and it gives us the last one, cube root of 2 cosine of 280 plus r sine of 280. Please understand that this 120 degrees difference, they are spaced at 220 degrees. So it's pretty straightforward. All right, this is, I want to quickly, and you're not responsible for it, but I want to quickly spend a couple of minutes on the Morse theorem and show you that, if just remind you how proof works. We said when z is r cosine theta or r cis theta, and z to the power of n is r to the power of n cis n theta. So the way you do that, by induction, you start with n equals 2, you raise this to the power of 2. So cosine squared plus 2 cosine theta sine theta times I, and plus I squared sine squared. I squared is -1. So this is what you get. So cosine theta plus I sine theta times cosine theta plus I sine theta. You do the foiling. And please understand, when you raise this to the power of 2, this becomes minus because it's I squared sine squared. And so if this is I squared sine squared, these two, okay, cosine squared minus sine squared, these two are the same as cosine of 2 theta. Now, what about this one? 2i sine theta cosine theta. Everybody knows 2 sine theta cosine theta is sine of 2 theta, right? So it works for n equals 2. What about 3? Raise this to the power of 3. To raise this to the power of 3, we are going to multiply cosine theta plus I sine theta by this one, right? And so distribute. Before I distribute, I'm going to change this to this one. This one, right? So distribute and we get cosine theta, cosine 2 theta plus cosine theta, sine 2 theta times I. So I, okay, cosine theta, sine theta. We multiply these two, we get I sine theta, cosine 2 theta. And if we multiply these two, we get I squared sine theta, sine 2 theta. I squared is -1. Now, if you combine these two, cosine alpha cosine beta minus sine alpha sine beta is cosine of alpha plus beta. So this is cosine of theta plus 2 theta. This one, sine alpha cosine beta plus cosine alpha sine beta is sine of alpha plus beta or sine of theta plus 2 theta. So put the green parts together, put the red parts together, and you see that when n equals 3, it's cosine 3 theta plus I sine 3 theta. By the way, we are taking R to be 1, okay? So that works. For n equals 2, for n equals 3. Let's do one more, n equals 4. If we want to raise this to the power of 2, that means cosine theta plus I sine theta times cosine theta plus I sine theta to the power of 3. This part we pick from the previous part, which we said this is cosine of 3 theta plus I sine of 3 theta. So this one, we pick it from there. And now we're going to distribute. So we distribute the cosine, and then we distribute the I sine theta. So this gives us cosine theta, cosine 3 theta, and cosine theta, I sine 3 theta. This gives us, we put the I in front, I sine theta, cosine 3 theta, and these two will give us I squared, sine theta, sine 3 theta, I squared is -1. So if you look at this last, the ones in red, the first and the last one, cosine alpha, cosine beta minus sine alpha, sine beta, again, cosine of theta plus 3 theta. And this one is, if we factor the I out, sine theta cosine 3 theta, that means sine alpha cosine beta cosine plus cosine alpha sine beta is sine of alpha plus beta. This is what we get. And therefore, we proved theta plus 3 theta, of course, is 4 theta. We proved that it works for n equals 4. Continuing this process will result in cosine theta plus I sine to the power of n equals cosine n theta plus I sine n theta. And if you happen to have a number in front of it, you want to raise it to the power of n, that number, we don't have to worry about it. That does get, if you happen to have R here, of course, you get R here. Okay, so believe it or not, that is the proof.